welcome to Explain Everything on Freefall. First, let's start with the basics of Freefall. Freefall is when the only force acting on an object is gravity. For the Earth, the acceleration due to gravity is 9.8 meters per second squared. This means that as an object falls, it speeds up 9.8 meters per second every second. Another way of saying this above is that as things fall, their speed increases, but their acceleration is constant 9.8 meters per second squared. So there are two equations for freefall. You can identify these equations as the freefall equations by the presence of small g, the acceleration due to gravity. These equations are valid only for something in freefall, ignoring air resistance and starting from rest. And the two equations are v equals gt, where v is an instantaneous velocity, and d equals 1/2 gt squared, where d is the total distance fallen in the time period t. So the first problem we're going to work out together. To make our calculations easier, we will use 10 meters per second squared for g. So the question is, how fast will a ball be traveling after 7 seconds? So we're going to start by identifying our variables. And how fast would be velocity? So I'm going to do v equals question mark. And 7 seconds. Seconds is a unit of time. So I'm going to do t equals 7 seconds. And then I see that since this is something that's falling, it's a free fall. So we always use little g equals 10 meters per second squared. So now I ask myself, which free fall equation am I going to use? Would it be v equals gt or d equals 1/2 gt squared? Well, you can clearly see from the variables that we're looking for and what we know that it's going to be, the equation is going to be v equals gt. The third step is to plug in my variables. So v equals, g is 10, and t is 7, and 7 times 10 is 70, and the units would be meters per second, because this is a velocity, and I will put a box around my answer. Okay, next problem. How far will a dropped ball have traveled after 7 seconds? So this is a similar question, but instead of how fast, it's going to be how far. How far would imply distance. So d equals question mark. And time equals 7 seconds. My son is here with me and he's trying to participate. And then, of course, and then, of course, it's dropping, so it's still free fall. So it is g equals 10 meters per second squared. Honey, I'm making a video of how to work out these problems and putting it on the internet for my students. Okay.
Who are you talking to?
Honey, shh. Okay. So now I see that I have d, g, and t and not v. So I look at which equations that I can choose from, and the better choice would be d equals 1/2 gt squared. So then I plug in d equals 1/2 times 10 times 7 squared. And my son has just learned, please excuse my dear Aunt Sally at school. So I'm going to ask him, what is it that I should do first? Should I do an exponent or should I multiply?
Let's see. You should do exponent.
Very good. I should do the exponent first. So the exponent is 7 squared. So 7 squared.
Please excuse my dear Aunt Sally.
Okay, hush,
means
baby.
Pam does.
Okay, thank you. Okay, so that means that this is D equals 1/2 times 10 times 49. And so we can simplify this by going 49 times 10, which is 490, and half of that is 245. So the distance equals 200, Nicholas, quit bouncing, and 45, and the units would be meters. And I'll put a box around my answer. Okay, let's try a trickier problem. Sister Linda is standing on top of the school building. If she drops Katie's yoga pants over the edge and it takes 0.987 seconds to hit the ground, how tall is the building? Well, I'm going to go ahead and, just like always, identify my variables. So seconds means time. So I'm going to say that t equals 0.987 seconds. And how tall? What variable would that be? Well, would it be velocity or would it be distance? And I'm going to say how tall is distance, so I'm looking for the distance. And since Katie's pants are in free fall, we're always going to use G equals 10 meters per second squared. Okay, and again, I look at them and I say this would be using D equals 1/2 G T squared because there's no mention of velocity and we have to find the distance. So now we plug D equals 1/2 times 10 times, and I need to multiply 0.987 squared. And so I want to do this first because of order of operations. So I will put that into my calculator. 0.987 squared. And that gives me 0.974. And I'm going to multiply that by 10. And that gives me 9.74. And I'm going to divide by 2. And so the distance would be equal to 4.87. And since I'm looking for distance, the unit is meters.
Just to make sure that you're still listening, this was brought to you by the awesome Nicholas and Falling Aliens.
Okay, thank you, Nicholas. Problem. We're going to say that Katie's yoga pants fell a total of 25.8 meters. Since meter is a unit of distance, I'm going to say D equals 25.8 meters. How long? How long? What variable would that be? That would be time. Were they in free fall? Remember that yoga pants are so inappropriately small that we can ignore air resistance. Okay, so since the pants are in free fall, G is going to be equal to 10 meters per second squared. And again, we look at what we know and what we don't know. We have D, T, and G. So the equation that fits that is D equals 1/2 GT squared. Okay, so D, I'm going to plug in for T, is 25.8 meters equals 1/2 times 10 times T squared. Now this is a trickier problem because I've got to solve for T, so I have to be very careful of order of operations. I'm going to simplify that 1/2 times 10 is equal to 5. So that gives me 25.8 equals 5t squared. To solve for t, I need to get the t squared on one side and everything else on the other. So 5t means 5 times t. To undo a times, I need to divide both sides by 5. The 5's cancel out here, and 25.8 divided by 5 is equal to 5.16. So I have t squared, and be careful here because it's still t squared, is 5.16. So to solve for t, you want to take the square roots of both sides. And of course, the square root of t squared is the absolute value of t. The square root of 5.16 is 2.27. And the units are going to be seconds. So, I put a box around my answer. TIES, the program where St. Mary students mentor a 5th grader, is doing an experiment where it should be they throw eggs off the roof at St. Mary's. Little Sophia Hunton times that her egg took 3.8 seconds to hit the ground. So before I even write anything else, I'm going to just identify my variable. The time is 3.87 seconds. What was the egg's final velocity just before it hits? So V equals question mark. And I ask myself, is this in free fall? And it is. So it's going to be G equals 10 meters per second squared. It's a very common mistake for students to have a question like this up on a test and come up to me and say they don't have enough information to solve it. And of course, they're forgetting that they need to use the acceleration due to gravity, which is G. Okay, so I have T, V, and G. And again, I ask myself, which of the two free fall equations would I use? And it's V equals GT. So V equals 10 times 3.87. And so I can do that in my head. V is 38.7 meters per second. Okay, thank you very much for listening to this Explain Everything.